Hi everyone, and welcome to this video where I'm going to briefly cover blending modes, how they work and what makes them interesting, and all sorts of things like that. The images used as examples in this video were provided by Adobe Substance Designer, but they are used across a lot of creative applications. So I figured that we would have a quick discussion so you can learn how they work and learn how to use them a bit better. So blending modes is where you have multiple layers of digital content being blended or merged together in different ways. And the term blending modes generally refers to the way in which pixels are blended across layers, and it determines how the actual color value is calculated in the final result. So as I mentioned, the images we're going to use to represent these is a node-based visual representation in Substance Designer. However, some of the applications that use blending modes that these will be useful for, as the terms are synonymous across all of them, would be Photoshop, GIMP, Illustrator, After Effects, Substance Designer, Substance Painter, and many more. So let's move on. So blending two layers. So whenever you have multiple layers in a graphics application, you can blend them reasonably easily. In some instances, this may be as simple as maybe applying a mask or just grouping layers, or in Substance using a blend node or something like that. And in order to blend two layers, you obviously need two layers, and one will be defined as a foreground and one will be defined as a background, regardless of the application you use. So in Substance, we actually have foreground, background inputs on the blend node. In something like Photoshop, it will just use a hierarchy. So the image on top will be the foreground and the one lower down in the hierarchy will be the background. So one of the sort of default blending modes is copy. So if you actually don't adjust the blending mode in any way, by default it's usually on copy. And the way that this works is it will just place the foreground on top of the background. Reasonably simple, and the way in which you affect how the output of this varies is you actually change the opacity. So at 0 opacity, it would likely be just the background. At 100% opacity, it would be the foreground, and at 50, it would be about 50-50. So the pixel color will be sort of 50% background, 50% foreground. And it's kind of helpful if you just want detail from both images thrown in and you're not too fussed about specifics. So add, or linear dodge, is a blending mode that will add the foreground input value to each corresponding pixel in the background. So if we look at this image, we can see that we have a very pixelated foreground node at the top called instance. And that's kind of a nice representation of how each pixel in the image, regardless of how dense the resolution, each pixel has its own color value. So anywhere between 0 and 1 representing white and black. And here we can see that by adding this linear dodge, the value of, say, black, which might be 1, would be added to the value of the image that we're using as a background. So it's useful if you want an equal distribution between the layers, or if you're not too fussed about transparency. But what we can actually see in the final result of the node on the right is that as the pixel color in the top node gets lighter, the actual color of our sort of phoenix shape, green and blue shape, gets lighter as well. So on the darker pixels it's going to be darker, and on the lighter pixels it's going to be lighter. And that's purely because you're adding a lower value where the white is, because it's closer to 0. So it's a lower value than the 1 on the dark. Subtract is kind of like the opposite of add, surprisingly. The subtract blending mode will subtract the foreground input value from each corresponding pixel in the background. So if the result of the subtraction is lower than 0, then it's obviously capped at 0. We can't go lower than that. And it's useful if you want foreground detail where background pixels exist. So here we can kind of see that we have lost some of the background image, particularly where there's sort of no values to be subtracting. So multiply, the multiply blending mode will multiply the background input value by each corresponding pixel in the background. So in the foreground, sorry. So whereas previously we were adding and subtracting, multiply just multiplies those values. Now, one thing you have to watch out for, obviously, is that you can't really multiply by 0, so there won't be much of an effect. So where you have a really light colour, that blend won't really take effect. So you can see here that where we have the darker colours on the foreground to the left, the end image is darker on the left because it's multiplied by a greater value, much like how when we add a greater value. Add sub. So add sub blending mode works basically by taking the foreground and the background pixels and only sort of greater than 0.5 and adding them to the background. So foreground pixels with a value lower than 0.5 are subtracted from their respective backgrounds, and values greater than 0.5 are added. So here you kind of basically make your dark colours darker and your lighter colours lighter, because the lighter ones have a lower value than 0.5 and the darker ones have a higher value than 0.5. So max or lighten, so max will actually sort of give an overall lightening effect to the image. The max blending mode will pick the higher value between the background and the foreground. This is useful when you want to increase the overall brightness of your image. So this assumes that white is 1 and black is a value of 0. Min, so max was to lighten and min darken. So whereas max took the highest value between the foreground and the background on each pixel, the min will take the lower one. So it's almost exactly the opposite. And then that way, because the lower values are closer to black, for each pixel it will take the darker of the two pixels. Divide, so the divide blending mode will divide the background input pixels value by each corresponding pixel in the foreground. So again, much like how we've had add, subtract, multiply, we now have divide. The darker the foreground pixel, the lighter the end result, because the foreground color value is higher, therefore dividing the background color by a greater amount. So we can see here on the right of our output, on the right output image, we have a brighter image sort of towards the left. It's sort of gone almost entirely white there. Overlay, so this blending mode combines multiply and screen, which we're going to come on to. If the value of the lower layer pixels, so the background, is below 0.5, then a multiply type blending is applied. So go back to multiply if you're not sure. If the value of the lower layer pixel is above 0.5, then a screen type of blending is applied, and screen blending mode values of the pixels in the two inputs are inverted, multiplied, and then inverted again. The result is the opposite effect to multiply and is always equal or higher, as in brighter, compared to the original. So when you screen, your output will always be lighter than your input, as we can see on the output node on the right. Soft light. So the soft light blend mode creates a subtle lighter or darker result depending on the brightness of the foreground color. So again, here we can see that the image overall is a bit brighter, but it's a bit more brighter on the right because the foreground pixels are white, whereas on the left of the foreground instance node they're dark. So they still get lighter, but they don't get as light as on the right. So that's kind of an overview of the different blend modes. As I say, they can be used in a host of different applications, and in particular these were by Substance Designer. If you are using Substance Designer specifically and you would like more information, then go to this website, and that's where you'll see these blending mode images. Thank you for listening, and I'll see you next time.